Hello everyone. Today we will see the basics of industrial IoT. So industrial IoT, that is the industrial Internet of Things, it is a specialized application of the broader Internet of Things, and it focuses on the industrial and the manufacturing sectors, while the Internet of Things, that is the IoT, it connects everyday devices to the internet in order to enhance convenience and automation. And industrial IoT, it will extend this concept to the factories, power plants, logistics and other industries in order to improve efficiency, safety and productivity. Okay, so the key aspects of IIoT are enhancing working conditions, that is it enables real-time monitoring of machines, work environments and safety parameters, and the sensors detect the hazardous conditions and alerts the workers in order to improve the workplace and safety. Then the next point is increasing machine life, that is predictive maintenance using industrial IoT. Industrial IoT, it will help the it will help to identify faults before they occur, and it will reduce unplanned downtime. Then the smart sensors track the wear and tear, ensuring timely servicing of machinery, and thus they will improve the lifespan of the machines. Then the last point is optimizing the operational efficiency, where the industrial IoT, it allows for data-driven decision making, improving production lines and supply chains. And the automated real-time analytics, these will reduce the energy consumption, waste and operational cost, and the remote monitoring and control will enable seamless operations across the multiple locations. So by integrating the industrial IoT into industrial processes, companies can achieve higher productivity, cost savings and improved reliability, making it an important crucial component of industry 4.0, that is the fourth industrial revolution. Next, we have key differences between the industrial IoT and the automation. So here the industrial automation, it has been used in industries for decades to control the machines and the processes. But this industrial IoT, it brings a more advanced data-driven approach. And the three key differences between industrial IoT and the traditional automation are ubiquitous sensing, advanced analytics, and the IT tools and methodologies. So here in ubiquitous sensing, automation relies on predefined sensors and controllers in order to operate machinery based on set rules. Whereas in industrial IoT, it integrates wireless smart sensors across the entire system, and it will enable the real-time data collection from multiple sources, improving monitoring and the control. Then second is the advanced analytics, where the automation focuses only on the rule-based operations and the reactive maintenance, whereas this industrial IoT, it uses the artificial intelligence, then machine learning and predictive analytics in order to analyze data patterns, allowing for predictive maintenance, process optimization and better decision making. And the third point is IT tools and methodologies, where the traditional automation depends on the programmable logic controllers, that is the PLCs, and the SCADA system for control. But this industrial IoT, it integrates the cloud computing, edge computing, cybersecurity, and big data analytics, enabling the remote monitoring and real-time data processing and seamless communication across industrial networks. So next we will see in detail what is ubiquitous sensing in industrial IoT versus the traditional automation. Here the traditional automation, it uses specific sensors and actuators for controlling critical industrial machines and processes. That is, it is limited to predefined operations and works within a closed system. But industrial IoT and ubiquitous sensing, here the sensors and actuators are deployed extensively across the machines, systems and environments, and it enables the real-time monitoring of the machine health, operational tracking and emergency responses. and also it provides a broader and continuous flow of data and improves the efficiency, safety, and the maintenance. So this here ubiquitous sensing, it will enable the advanced analytics by collecting the data at a scale, that is a vast network of sensors will gather real-time data from the multiple sources. And you have predictive maintenance, where the artificial intelligence and the machine learning will analyze the sensor and the data in order to predict the failures uh, before they occur. And the next point is the process optimization, where the sensor data will help the industries in order to improve the productivity and reduce the wastage. And last point is the remote monitoring and control for the faster decision making, where the cloud-based analytics will allow the decision making from anywhere and improve the response of time and efficiency. Okay, so this was about the ubiquitous computing sensing. Then next is the advanced analytics in IIoT. Here, uh, the first point is the data extraction and the analysis, where the industrial IoT collects vast data from the sensors, actuators which are deployed across the industrial processes, and the advanced analytical tools and algorithms will extract the hidden patterns and insights from this data. Then next is more data variety as compared to the traditional automation, where the traditional automation uses the limited structured data for predefined operations, but this industrial IoT, it handles larger, more complex and diverse data sets, including the real-time monitoring, historical trends, and the predictive analytics. Then you have the benefits of advanced analytics in the industrial IoT. That is, it will enhance the working condition. Okay. That is, it will identify potential risk hazards, improves the safety, and ensures better environmental monitoring. Then second is increasing machine life, where the predictive maintenance prevents failures, it reduces downtime and extends equipment lifespan. And the third point is optimizing operational efficiency, where it improves the production, minimizes waste, and reduces the energy consumption. Next, we have IT methodologies in industrial IoT. Here, the industrial IoT, it will enhance the traditional automation with IT technology. That is, the traditional industrial automation, it relies on proprietary control systems like PLCs and SCADA. But industrial IoT, it will integrate modern IT solutions such as cloud computing, edge computing, artificial intelligence, and cyber security in order to improve the industrial processes. Key benefits of IT methodologies in industrial IoT are, the first is the availability of the talent pool, that is the IT professionals with expertise in data science, networking, and the cloud computing. These can easily adapt to the industrial IoT and reduces the need for specialized industrial automation engineers. And the second point is, that is the second benefit is the standardization, where the industrial IoT will follow open protocols and the international IT standards, making the integration across different systems easier, and it will ensure interoperability between the devices, platforms, and softwares from various manufacturers. And the third point is accessibility of IT hardware and software solutions, where the leverages existing IT infrastructure will reduce the cost and the implementation time, and it uses readily available cloud platforms, then databases and the artificial intelligence tools, and eliminate the need for custom built solutions. So this was about the IT methodologies in industrial IoT. Next, you have the challenges in industrial IoT. The first is data integration challenge. Then second is the cybersecurity, lack of standardization, legacy installations, lack of skills. These all are the challenges in the industrial IoT. So here the uh, these like IoT, it will enhance the traditional automation, and we will see what is Like here, the data integration challenges, it is related to system compatibility and the data silos, whereas the cyber security deals with the network vulnerabilities and the data breaches, and the lack of integration here, it deals with the protocol diversity and interoperability issues, and legacy installations, it is integration difficulties and upgrade challenges, and lack of skills is, that is there is a need of training and the skill development. Okay, now in detail we'll see what is first data integration challenge in the industrial IoT. So here, integrating the data from industrial IoT systems, it is complex due to the vast amount of information generated by various industrial devices, and the key challenges include big data volume, where the large scale industries generate massive amounts of data, making storage, processing, and real time analysis difficult. And the second point is complex and diverse data, where different sensors and actuators will produce varied data formats like structured, semi structured, unstructured, requiring the standardization. Then you have high data generation frequency, where multiple connected devices continuously produce real time data, and they will create the synchronization and process the challenges. Next point is data integration issues, which will combine data from various sources into a centralized system and ensures the accuracy and consistency as a major hurdle, which is a major hurdle. And understanding and applying the data in business, where you have extracting the meaningful insights from the raw industrial data, and which requires advanced analytics, artificial intelligence, and domain expertise that will make implementation difficult. Next, you have cybersecurity in the industrial IoT. So, cybersecurity, it is a very important and crucial aspect of the industrial IoT, because all the connected devices which interact with the real world, uh, and ensures the security, and these will ensure that the security will help to prevent the cyber threats, data breaches, and the operational disruptions. And the key security concerns in industrial IoT are the data privacy protection. You have information security, which will protect the sensitive industrial data from the unauthorized access, cyber attacks, and the system breaches. And the data privacy protection, it will ensure that private and business critical information is securely stored, transmitted, and accessed to only by authorized users. Examples of IIoT security, cybersecurity risk in industries are the healthcare industry, where data integrity, it is a very important, to prevent tampering with the patient records, diagnosis, and treatment plans. And the food industry, where the confidential company information such as recipes or the supply chains data must be protected in order to prevent the reputational damage. And next is the power grid, where a cyber attack on a power grid could lead to massive blackouts, and it will affect the industries and daily life. Next, you have the lack of standardization in IIoT, that is the industrial IoT. Here, the standardization is also important for seamless integration and interoperability in the industrial IoT. But the challenges arise here because of large automation suppliers, which will avoid open standards to maintain customer dependency, and the small automation suppliers, which will lack the resources to drive standardization efforts. And the issues are device interoperability, where the different manufacturers will use proprietary protocols, and makes it difficult for the devices to communicate with each other. And the integration of hardware and software from multiple vendors, it becomes complex and the costly. Then you have semantic interoperability, that is the data semantics, where inconsistent data formats and the definitions create challenges in the data exchange and the interpretation. And the lack of common frameworks will lead to miscommunication between the systems. And the last one is security and privacy, where inconsistent security measures across different devices will increase the vulnerability to the cyber threats, and the lack of standard privacy protocols will expose sensitive data to breach and unauthorized access. Then you have legacy installations in IIoT. So as the technology is rapidly evolving, integration modern industrial IoT system with legacy industrial equipment becomes a significant challenge, and many industries still rely on older machinery which will lack that are lacking the connectivity and computational power which are required for the industrial IoT. So the key challenges here are the coexistence and old and new technology. That is the technology gap, where the legacy kind of systems were not designed for industrial IoT, making integration difficult, and the retrofitting older equipment with sensors and the IoT interfaces is costly and complex. Second is the data compatibility issues, where older machines will generate limited or incompatible data formats and makes real-time analytics difficult. And also the need for protocol converters and the middleware solutions to enable the data exchange. Then you have security risk, where the legacy systems lack modern cybersecurity measures and make them vulnerable to cyber threats. And upgrading security without disrupting operations, it is a major challenge. Next, you have high cost replacement or high upgrade cost, where replacing legacy equipment with industrial IoT compatible systems requires huge investments, and many industries prefer gradual upgrades through hybrid solutions. These are the legacy installation challenges in the industrial IoT. Then you have next challenge is the lack of skills in industrial IoT. The adoption of the industrial IoT, it faces a major challenge because of the limited availability of the skilled workers. And the industrial IoT, it requires expertise in multiple areas, but many workers, they will lack the necessary knowledge and the training. So the key reasons for skill shortage are uh, new and evolving technologies, that is the industrial IoT. It integrates AI, cloud computing, cybersecurity, and the big data, which are relatively new to traditional industrial workers. And the rapid advancement will make it hard to keep up with the emerging trends. And you have need for diverse skill sets. That is industrial IoT professionals must understand both industrial operations and the IT technologies, and the skills in data integration, networking, analytics, and automation are essentially, but these are not like widely available. So this all will have impact on the skill shortage. That is the slower the industrial IoT adoption, and it will delay in digital transformation. Then increased reliance on external experts and consultants will raise the cost. So the solution for this is industries must invest in training and upskilling programs in order to bridge the gap. Next, you have applications of the industrial IoT. The first is healthcare industry, then you have mining, manufacturing, transportation, and logistics and firefighting. Healthcare industry, here you'll be having the remote patient monitoring and real-time health tracking, and smart medical devices for automated diagnostic and the treatment. Then in mining industry, you will be like predictive maintenance of heavy machinery in order to prevent the breakdowns, and the real-time monitoring of worker safety and the hazardous conditions. Then you have manufacturing industries, where smart factories with automated production lines and the quality controls are required, and energy optimization and predictive analytics for machine maintenance is also required. And here in transportation and logistics, you will be having fleet management with GPS tracking and real-time route optimization, and supply chain monitoring for efficient inventory and delivery management. Then in firefighting, you will be having smart fire detection, which uses the IoT sensors and the AI based alerts, and the real time tracking of firefighters and the fire hazards for improved safety. Now we will see one by one, that is the applications. So industrial IoT in healthcare. So here the industrial IoT, first you have like here the first point is the doctor selection. Okay, and the second point is the connected medical devices, and you have medical research. So coming to the just a minute. Coming to the doctor selection, the patients can access the doctor ratings, reviews, and the credentials for better choices. And here, whereas in connected medical devices, it will track the device location, and it will track the status and patient monitoring in real time. And then you have medical research, where big data and AI, these will improve the disease prediction, treatment, and the drug discovery. Okay, so in healthcare, here the IoT, it will play very important role in improving the healthcare services by enhancing the connectivity, data availability, and the real-time monitoring. Now in connected, we have seen like a better doctor selection, connected medical devices, and the medical research. Then you have IoT, industrial IoT in mining industry, where IoT will leverage the sensor networks, RFID tracking, and wireless connectivity in order to enhance the safety and efficiency in mining operations. And the key components and their functions are gas sensors, which will detect oxygen levels, methane, and poisonous gases in order to prevent the hazardous situations. Then it will have it will trigger the early warnings in order to protect the workers from gas leaks or the explosions. Then you have strata and the rock mass monitoring, where it will analyze mine stability, and it will do this by detecting the structural changes. It will prevent cave-ins and collapses by providing real-time alerts. And RFID tags for miner tracking. Here you'll be having real-time tracking of miners inside the underground tunnels, and it will help in emergency rescues and ensures worker safety. Then you have Wi-Fi and wireless networks, where it will provide the seamless communication between the surface and underground operations. And also it will enable remote monitoring, data transfer, and automation of mining processes. Okay, so the key benefits of these are early disaster warning in order to prevent accidents. Then it will monitor the miners working conditions and safety, and it will improve the tracking and the locating miners in emergencies. And it increases operational efficiency through automation and the real-time data sharing. Then you have smart manufacturing, where it is the advanced approach to industrial production, which will integrate devices, then equipments, workforce, supply chain, and other work platforms. And these all will be combining into a connected and intelligent ecosystem. And here the key benefits are, first is a reduction in the operational cost. Okay, first was this integration of the technology, where it will combine all this. And second is the reduction in operational cost, that is by automating repetitive tasks and optimizing resource utilization. Smart manufacturing will minimize production cost, and the predictive maintenance, it will prevent the equipment failures, then reducing downtime and maintenance expenses. Then you have efficiency of the workforce. Okay, that is a workforce efficiency, where automation and AI driven systems will assist the workers in complex tasks, and it will enhance their productivity. And the digital tools will provide real time data and insights, and these will enable faster decision making. Then you have improved workplace safety, where the smart sensors and monitoring systems will detect the hazards in the real time and prevent the accidents. And the robotics and automation will reduce the human involvement in dangerous risk tasks. Then you have resource optimization and waste reduction, where the data analytics will help in precise material usage, then reducing waste generation, and energy efficient machinery. These will lower the power consumption, contributing to sustainability. Then you have end-to-end automation, where the integration of AI-driven robots, cloud-based control systems, and digital twins. These will ensure seamless automation of manufacturing processes, and this will result in the high accuracy, consistent quality, and faster production cycles. And last, you have which will combine these both, that is end-to-end automation and the enhanced productivity and sustainability, where it will lead to the higher efficiency, consistent quality, and the eco-friendly practices. Then you have smart transportation, where the transportation and the logistics, these will leverage the connected devices which are like deployed sensors, GPS, and the real-time monitoring systems, and these will enhance the efficiency, safety, and the performance. And these technologies enable the seamless tracking of equipment, engines, and the tracks, and improve the overall operations. And first point, or the key benefit here, is the real-time monitoring, that is the easy monitoring of equipment and the infrastructure, where the connected sensors and the IoT devices, these will help these will help to track the health and the performance of the vehicles, engines, and these will track in the real time. And you have GPS and RFID systems, which will provide the precise location tracking of shipments and the fleets. Second is data driven analysis for improved decision making, that is a predictive maintenance. Here you'll be having continuous monitoring, which will generate large volumes of data, and here this will be analyzed, and this will provide insights into the maintenance needs. Okay, then status and performance, that is the performance tracking and the optimum scheduling. Maintenance needs, here the predictive maintenance, this will prevent the breakdowns, and it will reduce the repair cost and downtime. Whereas the status and performance, that is performance tracking, here the real-time performance tracking will ensure vehicles and the equipment operate efficiently. And last is the optimum scheduling, where the AI based scheduling will optimize delivery routes, reduces delays, and improves the fleet utilization. Okay, and the operational efficiency and the cost savings, that is cost and safety improvements, these will reduce the downtime and the fuel consumption through predictive analytics. These will improve the safety by detecting mechanical issues before failure occurs, and better planning and resource allocation through intelligent scheduling. And coming to, it is continued, that is the smart transportation. So here optimum scheduling, it is achieved through AI based route planning, real time traffic analysis, and the automated fleet management. And this will help in providing better customer service by minimizing cancellations and delays, and optimizing travel and delivery schedules, and reducing fuel consumption by efficient route planning, which reduces the unnecessary travel and idle time, saving fuel, and lowering the operational cost. And second is the proper maintenance equipment, where regular and predictive maintenance of transportation equipment, and which includes vehicles, engines, and infrastructure, will ensure enhanced safety for passengers and machines, which will prevent the mechanical failures, then reducing accidents and ensuring smooth rides. And the lower maintenance expenses, these will detect and fix the uh, minor issues in the early stage, and it will prevent costly breakdowns and the emergency repairs. Then you have smart firefighting. Smart firefighting, in modern firefighting, it utilizes sensor networks and RFID, that is a radio frequency identification tags, in order to enhance the disaster response, early detection, and real-time monitoring. These technologies, these will play a very important role in making emergency rescues faster and more effective. And key benefits of smart firefighting systems are real-time monitoring, fast and automation diagnosis, then more effective emergency rescue. So real-time monitoring, here the sensors will detect the smoke, heat and gas leaks, while the RFID tags will track the firefighters and the equipment. And in early warning of disaster, here the automated fire detection and alerts will ensure the quick response. And fast and automatic diagnosis, here AI powered analysis predicts the fire spread and it will activate the fire suppression systems. And last is the effective emergency rescue, where the live tracking and smart communication system will enhance the rescue operations. The key impact of these are faster fire response, then reduced damage and improved safety for firefighters and civilians. And the benefits are, it will enhance the connectivity. Okay, that is, it will improve the connectivity among the devices, and it will enable seamless communication between machines, sensors and the control systems. And also it enhances real-time data sharing and decision making. Second is, it will boost the operational efficiency, that it will improve the operational efficiency and it will automate the processes to reduce the errors and optimize resource usage. And the predictive maintenance, it will prevent the downtime and enhances the system reliability. Then improves the productivity, where it speeds up the production with automated and data driven decision making and reduces the manual intervention, leading to faster and error free operations. And it optimizes the asset utilization, where it will monitor and manage machinery performance for maximum efficiency, and it will reduce the idle time and it will increase the lifespan of industrial assets. Then you have it will create new jobs and business opportunities, where it will encourage the development of new industries and tech driven job roles. And also it opens markets for industrial IoT based services and innovations. Then you have reduces operation time and enables remote diagnosis, that is, it will allow for remote monitoring and troubleshooting, and it will reduce the need for on-site visits. And also it increases the response time to equipment failures or inefficiencies. And next point, you have cost effective, that is, it will lowers the energy consumption and reduces the maintenance cost and minimizes the waste and improves the supply chain efficiency. Then it will enhance the worker safety, that is, it will boost the worker safety, where smart sensors will detect the hazards like gas leaks, overheating or system malfunctions. And wearable industrial IoT devices, these will monitor the workers health and safety conditions. And also it provides a customer insights, that is, it will provide in-depth knowledge of the customer demand, and it will analyze real-time market data in order to predict the customer preferences and enhance the customization and responsiveness in the production. These are the benefits of the industrial IoT. So overall, the industrial IoT offers various numerous advantages such as improved efficiency, then predictive maintenance, real-time monitoring and cost savings. But its implementation comes with challenges like cybersecurity risk, high initial cost, integration complexities and data management issues. So despite these barriers, the future of the industrial IoT, it remains bright. Instead of dismissing its potential, industries should strategically deploy industrial IoT in areas where challenges are minimal and easier to overcome. For example, industries with strong digital infrastructure and robust security measures can benefit significantly from the industrial IoT. And also the sectors like manufacturing, logistics and energy, where automation and real-time monitoring can enhance the productivity, are ideal for the industrial IoT implementation. Okay, and by focusing on such areas, businesses can maximize the benefits of industrial IoT and minimize risk and operational operational challenges. Okay, so this was about the basics of industrial IoT. Thank you.